Hello everyone, and we are Group 9, and I am Luigi Cadillo presenting our work. And in this video, we are going to explain the applications of Venn diagram, its different parts and uses in real-life situations. First, let's explain what is Venn diagram is. That Venn diagrams are flexible tools that support critical thinking, problem solving, and decision making in a variety of contexts. It is comprehensive to comprehend how they are employed in real life.
Venn diagrams enhance classroom learning by providing visual representations of ideas, connections, aiding in better understanding of complex concepts, and enhancing analytical abilities by contrasting and analyzing data, such as literary works.
Venn diagram helps us in business analysis, decision making, problem solving, event organization, resource allocation, dispute resolution, and daily life by organizing information and identifying patterns and visual connections between demographic variables, purchasing habits, and brand loyalty, enabling efficient time management and goal achievement.
Hello, I'm Mark Warren Gonzalez presenting our output. Today, we will be discussing the Venn application, and this is our problem set number 1. In the application of Venn diagram, the question is a survey of 60 people was taken and showed the following results. Within 12 customers drink tea and coffee, 6 customers only drink juice, 29 customers sip tea, 2 customers consume only tea and juice, 10 customers drink tea, coffee, and juice, 33 customers sip coffee, and 1 customer consume only juice and coffee. Now we are going to answer the following questions. For A, how many customers grab only juice? Letter B, how many customers run only coffee? Letter C, how many customers drink only? And for letter D, how many customers did not drink juice, tea, or coffee? So we can see that there are 3 events. We have tea, juice, and coffee. Given that there are 60 people and the 12 customers only drink tea and coffee, we're going to put 12 in the intersection of tea and coffee. Where is tea and coffee? So this is 12. Next, 6 customers drink juice only. So we're going to write 6 in the juice area. So we are done here. And in this given, 29 customers drink juice. So we could take note that this is the total number of people who drink tea. So we will go back to this given because we don't have enough given in our Venn diagram number. Fourth is given is 2 customers drank only tea and juice. We write 2 in the intersection of tea and juice. Next, 10 customers drank tea, coffee, and juice at the intersection of the 3 events. There were 10 who consumed all 3, tea, coffee, and juice. We're done in this part. Now, 33 customers drank coffee, so since we weren't we weren't given or we don't have yet the intersection of juice and coffee, we'll be back later, but this is crucial, so we have to note this. Next, only 1 customer sip juice and coffee, juice and coffee, and this is what we needed for the previous given. Now, so since we have the given for the juice and coffee intersections, let's analyze them. So there are 33 who drink coffee all in all. Now we have to solve for those who only drink coffee. Some of the previous given were 12 of them drank coffee and tea. So we have to deduct 12 from 33, which results in 21. 10 of the customers drank tea, coffee, and juice. So 10 deducted from 21 is 11. And lastly, 1 customer consumed only juice and coffee. This is what we needed for the previous given. Now, so since we have the given for the juice and coffee intersections, let's analyze them. So there are 33 who drink coffee all in all. Now we have to solve for those who only drink coffee. Some of the previous given were 12 of them drank coffee and tea. So we have to deduct 12 from 33, which results in 21. 10 of the customers drank tea, coffee, and juice. So 10 deducted from 21 is 11. And lastly, one customer consumed only juice and coffee. I 1 deducted from 11 is 10. Now we have 10, which means that this is the number of customers who only drink coffee. Next, 29 customers drank tea. Let's also go back to the previous givens and analyze them. The number of customers who only drink tea is missing, and here we also be doing what we did to get the number of customers who only drink coffee. We have 29 customers who drink tea. 12 of them also drink coffee, so we have to deduct it from 29, which is 17. 2 of them drink juice and tea, deducting it, resulting in 15. And lastly, 10 customers consume tea, coffee, and juice, deducting it from 15 is 5. Now we have 5 customers who drink tea only. Next, adding all the numbers of customers, which are 5, 12, 10, 10, 2, 1, and 6, results to 46, which we have to conduct from the total number of participants who participated in the survey, which is 60. 46 deducted from 60 results to 14, which means that the 14 did not drink any of the drinks available. Let's answer questions from this problem set. First, how many customers drank only juice? So there were 6 customers who only consumed juice. Second, how many customers sip only coffee? There were 10 customers. How many customers drink tea only? There there were 5. Lastly, how many customers did not drink juice, tea, or coffee? There were 14 customers who did not drink any of the three. And we're done. I hope that you get 4 out of 4, but it is also good if you made 3 or 2 out of 4. Just be careful in writing our Venn diagram since this is very crucial. If you made a mistake, then of course, all the remaining questions will give you a hard time getting the correct answer, or you be completely wrong. That's all. Good luck.
Today we will solve this problem number 1. A survey of 72 students showed that 34 students wish to travel to Boracay, 30 students wish to travel to BGC, 28 students wish to travel to Batangas, 15 students wish to travel to Batangas and BGC, 10 students wish to travel to Boracay and Batangas, 12 students wish to travel to BGC and Boracay, while 8 students wish to travel to all 3 destinations. And this is our 2 questions. How many did not wish to travel any of these destinations? And our question number 2, how many wish to travel to exactly one of these destinations? So let us solve it. First, we will need our 3 Venn diagram because we have 3 variables. And next to that, we will put the number 8 in the middle. So let us start. First, we will subtract 15 to 8, which will give us 7. And we will put that in the between BGC and Batangas.
And next, the students that wish to go to BGC and Boracay are 12 students. And 12 minus 8 will give us 4. And next to that, Boracay and Batangas, the students that wish to go there are 10 students, which 10 minus 8 will give us 2. So, first, we will we will need to, in order us to get the number of students that want to go to Batangas, first we need to add 7 plus 8 plus 2, which will give us 17. And 17 minus 28 will give us 11. And next, we will we will know how many students wants to go to BGC. First, we need to add 7 plus 8 plus 4, which will give us 19. 19 minus 30 equals 11. And in Boracay, the number of students who wish to go to Boracay are 34 students. So, in order us to get the answer, we will need to add 2 plus 8 plus 4, which will give us 14. 14 minus 34 is 20. So, in order us to answer the question number 1, we will need to add all of the numbers that are inside in this Venn diagram. So we will add it. It will be all 63. And we will subtract 63 to the total number of students, which is 72. 72 minus 63 is 9. So that is the answer in question number 1. And the answer in question number 2 are the total here in this Venn diagram, which is 63.
And now, we will be discussing problem set number 2. In our problem set number 2, we have 75 college students were asked by student councils who were conducting a research about their prepared ice cream flavors amongst chocolate, vanilla, and strawberry flavored. Set number 1, 38 students prepared chocolate flavors only, while 30 students prepared vanilla ice cream flavored only, and 28 students prepared strawberry flavored ice cream. 18 both liked strawberry and chocolate flavored. 15 both liked chocolate and vanilla flavored, while 9 students both liked vanilla and strawberry flavored. 7 students only like all the preferred flavors. So our question in this problem set is number 1. How many students only preferred chocolate ice cream flavored? Number 2. How many students preferred vanilla flavor only? Number 3. How many students preferred strawberry ice cream flavor? And number 4. How many students do not prefer only of the 3 flavored ice creams? So, in this problem, we will be solving for the following questions shown in the chart. Now, let's illustrate the Venn diagram. In the Venn diagram, we will be starting at the middle part. And our answer will be 7 because 7 students prefer all of the flavored ice creams. For the next step, we will be solve for the intersections of the variant to get the correct answer. We will be subtract the given with the intersection within the 3 variants, which is 7. So, 7 minus 18 will give us 11. 11 is the answer for the intersections chocolate and strawberry flavored. And now, do this for all other intersections. 7 minus 9 is equals to 2 and 7 minus 15 is equals to 8. The answers should be 8 for strawberry and vanilla and 2 for chocolate and vanilla. And now, let's move on to getting the answer for each circle. We will start with the strawberry circle. In strawberry circle, we have 11, 7, and 8. Just added them up so we can get 26. So our given is 26 minus 28 will give us 2. So 2 students prepared strawberry ice cream flavored. Now for chocolate circle. So we have 11, 7, and 2. 11 plus 7 plus 2 will give us 21. Then 30 minus 19 is equals to 11. So 11 students prepared chocolate flavors ice cream. Next is vanilla. Now for vanilla circle, we have 7 plus 2 plus 8. It will give us 17. Then 17 subtract to 38 will give us 21. So 21 students prepared vanilla ice cream flavors. Now, let's add all of the numbers in the Venn diagram and subtract it to 75, which 75 is our universal number. 75 minus 62 will give us 13. 13 is the answer for our question number 4. Now, we can answer the questions correctly based on the Venn diagram we created. So, our answer for number 1, how many students only preferred chocolate ice cream flavors, is 11. For number 2, how many students preferred vanilla flavored ice cream only, is 21. For number 3, how many students prefer strawberry ice cream flavor? The answer is 11. And for number 4, how many students do not prefer only of the 3 flavored ice cream?
Hello, I'm Karag John Paul, presenting our work, and today we will be discussing about the Venn diagram application, and this is our problem set number 4. The first problem, a survey of 120 students from MMCL, a survey of 10 students showed that 50 wish to travel to Japan, 43 wish to travel to South Korea, and 37 wish to travel to Singapore. From these 24 wish to travel to Japan and South Korea, 16 wish to travel to South Korea and Singapore, and 13 wish to travel to Japan and Singapore. And finally, 9 wish to travel to all 3 destinations. Now the questions are, how many did not wish to travel to any of these destinations? And how many wish to travel to only exactly one of these destinations? So, let's head to the solution. Let's start by having a 3-circle Venn diagram since we have 3 variables. We have Japan, South Korea, and Singapore. They will be labeled as, so by looking at the list of given, let's turn our focus to the bottom bullet since 9 is the number of those who wish to travel to all 3 destinations. It belongs to the center of to travel to Japan and Singapore. This belongs to the intersection of Japan and Singapore. However, the value is incorrect since we already have 9 in the center of the diagram. This would mean that 9 is already a part of 13 to solve for the true value we need to subtract 9 from 13. This would give us a value of 4. Now we need to do the same for the other values. 16 minus 9 would mean that 7 would be the total for the South Korea and Singapore. 24 minus 9 would give us 15 for the total of Japan and South Korea. Now that we all have these values to get the final values for Singapore, Japan, and South Korea, we would need to add all of the values from all its intersections and subtract it from the given total. So the total for Disney World is 37. So we would need to subtract 4, 9, and 7 from 8. And this will equal to 7, making it 17 for only Singapore. 15. So for the part 2, 9 minus 15 and 7 from South Korea would equal to 12, and 50 from Japan minus 15 minus 9 and 4 would equal to 22. Inside the Venn diagram and subtracting, 86,
So 86 minus 120 would give us 34, and now 34 in order to answer the first question. So we would need to add all up the values it has given from the total of 120 students. Adding up all the values would give us 34, would be the total of those who do not wish to travel to any of these destinations. And now for the second question. We only need to add up all the values that are not inside the intersection. This would mean that 22 plus 17 plus 12 would give us a total of 51 students who wish to only travel to one of these locations. And this is all for this.
So in the end, the conclusion is that the Venn diagram stands as a timeless emblem of clarity, guiding us through the intricate realms of comparison and contrast. Its elegant circles, intersecting in harmonious union, represents the convergence of ideas, the blending of concepts, and the revelations of commonalities amidst diversity. As we read forward this visual tool, let us not merely see it as a diagram, but as a testament to our pursuit of understanding, a beacon illuminating the pathways of knowledge. May its legacy continues to inspire curiosity, foster insight, and facilitate discourse in the ever-expanding landscape of human thought. Once again, I am Luigi Carillo, and we are Group 9 presenting our work. Thank you for watching.